Today on My Climate Journey Startup Series, our guest is Eloa, co-founder and CEO of Beyond Aero. The emissions from aviation are a tricky topic. There's no doubt that flying is a convenient and in many ways necessary component of our global society. And while COVID lockdowns helped retrain many of us who maybe previously defaulted into flying a bit too frequently, there's no question that modern society depends on air travel. But the solutions to air travel from an emissions standpoint are a challenge. Aviation accounts for over 2% of global emissions. Lithium-ion batteries are heavy, which doesn't really pair well with flight. Sustainable aviation fuel is one potential solution and has promise as a drop-in replacement for kerosene. But what about hydrogen? At Beyond Aero, Eloa is redesigning the small business jet, or private jet as it's more commonly referred to, from the ground up with hydrogen as a fuel source. We touch on all sorts of topics, including why hydrogen is a good potential solution for this category of aircraft, why France is leaning in heavily to hydrogen-powered aviation, how Beyond Aero has designed its solution, and how Eloa sees the market evolving. But before we start, I'm Cody Sims.
I'm Yin Lu.
And I'm Jason Jacobs. And welcome to My Climate Journey.
This show is a growing body of knowledge focused on climate change and potential solutions.
In this podcast, we traverse disciplines, industries, and opinions to better understand and make sense of the formidable problem of climate change and all the ways people like you and I can help. Eloa, welcome to the show.
Nice to meet you, Cody.
Well, I'm excited to have this conversation and to learn from you because you're tackling a substantial climate problem that feels like one of those areas that is really challenging, which is the entire space of air travel. There are a few different solutions that are out there right now, or proposed solutions, but it seems like the industry hasn't fully aligned yet on where things will go. And maybe I'm going to anticipate a little bit about what I might hear from you, which is you actually need to break the problem down into different categories of air travel potentially and address those categories somewhat differently. Without further stealing your thunder, maybe introduce yourself and introduce a bit about Beyond Aero.
Yeah, absolutely. You're right. Aviation will be electric one day. For me, it's a question of when, who, which market first, which technology. You're right, some are going to use lithium batteries for short range. We may use hybrid, and you have hydrogen propulsion. But it's happening. And especially in Europe first, we will talk about that, but this is where everything has started already, and it's happening. I'm very happy to be with you today. I'm Eloa, co-founder and CEO of the company Beyond Aero, and we are building business aircraft, electric business aircraft, powered with hydrogen propulsion. So it's a small aircraft, it's a 6-seater. We use gas, hydrogen, fuel cells, and electric engine to fly on 1,000 miles.
And just to state the obvious from the outset, when you say we're building an aircraft, you're literally designing and building an aircraft from the ground up. You're not a propulsion solution or a hydrogen storage solution. You are doing that, but you're also reimagining what these aircraft look like, yes?
Yes, that's the whole challenge, that today we bet on the fact that the technology exists. Well, it does exist, but will evolve. I mean, the subsystem exists already. We can buy the electric engine, we can buy the fuel cells, the hydrogen tanks, and more of the subsystem. And you're right, our position is really to redesign an aircraft architecture around the powertrain. So the core IP of the company is to design a special case about where do you put the tanks. The hydrogen tanks are volumic, massive, heavy. If you try to retrofit an existing aircraft, you lose most of the range, most of the cabin. It could work on a technical point of view, and that's what we have done with our prototype. But then the whole complete business model is to redesign. It's called build to spec. So you design it, and then you work with suppliers to build it, and we are the final assembler. And then the business model is to sell the aircraft.
So there are a few different angles I think we can tackle in our conversation, things I'm going to want to explore. One is understanding the different classes of aviation and different potential solutions therein. And then the other is understanding hydrogen and some of the design challenges inherent in hydrogen as a solution. Why don't we start with the latter? Let's start by understanding, if you are coming from first principles and saying, let's build a jet powered by hydrogen, why do you feel the need to fully reimagine the layout of the jet in the first place? And where did you land in terms of the design that you've created?
So step by step, how does the propulsion system works? First, you tell me if I'm going too much in detail or not enough, but basically, hydrogen is a vector of energy. So you store it in tanks, could be liquid or gas. We have chosen gas as a first step. You store it at high pressure. The hydrogen goes into a fuel cell. A fuel cell will create electricity from hydrogen and the oxygen of the air from outside. So you put hydrogen and oxygen to create H2O. The fuel cell emits water, electricity, and unfortunately, that's the downside, a lot of heat. So that's one of the key challenges. You need to cool down the fuel cells. And then from the fuel cell, you can power the electric engine. So the electric engine will be powered from the fuel cell and not the usual lithium batteries as we are used to. So that's a powertrain. This is not something new. This exists already in boats, in cars, in trucks, even in some prototype for aviation. What is new is to design the aircraft around it. Because if you do a retrofit, you need to find a place for the tanks. And they weigh about 1 ton. It's huge.
Or do they weigh more than the equivalent amount of traditional jet fuel?
Unfortunately, yes. Electric aircraft, we cannot have as much range as a thermal aircraft have. That's why I said 1,000 miles. But with hydrogen, we can go 5 times further away than lithium batteries. So you asked a question about the design, then that we have built this powertrain first, and then for 2 years, we have worked on the architecture of the aircraft around it. So 2 main questions. The first one is, where do you put the tanks? Where? Could be above the cabin, below, on the wings, above the wings. Some are putting them below the wings, etc. We, that's one of our core IP, have decided to put them below the cabin for balance reason of the aircraft, but also in a non-pressurized area. So in a kind of a belly of the aircraft. And they are also protected by a structural beam in the middle that is larger than the tanks.
Where are they stored traditionally on an aircraft?
For jets,
the jet fuel, yeah.
The kerosene tanks are in the wings. So our design, the aircraft has thinner wings, a bit larger also with wider wingspan and long winglets. So that's one of the key elements is the position of the tanks. The second one is a cooling system. I was telling you about the fuel cells. They emit a lot of heat, as much as heat as electricity. So you need to have somewhere on your aircraft an air intake system to take the air from outside and cool them down. And so we have designed an air intake system above the fuselage between the 2 electric engines, and the fuel cell would be behind the cabin. And that's another core IP of the company. So to really summarize, it's really about how to design an aircraft made for hydrogen propulsion. It's called the clean sheet design. That's the aerospace term that we use. Clean sheet design aircraft made for hydrogen propulsion. It's the only way to reach 1,000 miles.
Just to clarify something you said, you are building this as a fuel cell design, so you are not combusting the hydrogen. You are running this through a fuel cell. You're ultimately then turning it into electric power that powers, I assume, propellers to drive the plane, which you can, I think, combust hydrogen. So that would be a different design choice, but not as low of an emissions profile as a fuel cell design. Is that correct?
You're absolutely right. We use 2 electric engines powered from 2 segregated powertrains for safety reason and certification reason. I said it a bit at the beginning, but our strategy is to really buy existing components on the shelf and bet on the fact that we are going to be the first one on the market by maybe not building the most efficient ever, because you're right, turbo combustion chamber would have a longer range. But with a clean sheet design, existing fuel cells, gaseous hydrogen, we could still reach 1,000 miles. And 1,000 miles is 80% of the market. It's the main airports that travel below 1,000 miles, and even the main 5 airports of Europe, London, Paris, Geneva, Nice, and then you go to Madrid, Berlin, it's even below 500 miles. That means that we could go back and forth only with one refueling. So for me, the combustion chambers or liquid or everything will arrive later. But as a startup, we start with everything on the shelf, integrated everything fast in the new clean sheet design, where is the market is strong also. Happy to discuss about that. And also the certification timeline. It's all about safety first and certification in aerospace, as you may know.
Let's talk about that. So from a hydrogen perspective, I presume there are, I'm guessing, two major safety issues, one being the volatility of this gaseous hydrogen in the first place. And then the other is, as you mentioned, the actual fuel cell process generates a lot of heat. And so, if you have a problem with overheating there, you also have a problem. Are those the two big ones, or are there other things that need to be under consideration as well?
They are the main one. Then you have 100 things, for sure. Smaller one. Another one is a compressor to compress the oxygen from outside, because the more you go in altitude, the less you have pressure, as you know. So you need to compress the air from outside. That's another subject. But each time, all of these subjects, it's always the same. We buy existing components and then we assemble everything with new design, with new architecture of the powertrain.
Yeah, talk about each of those and how your design attempts to obviate those challenges.
That's where I can't really go into detail because we have patents
okay.
on the thing. But I can say about the compressor, it's really one of the big subjects. You have also the high voltage because of the altitude, 800 volts. That's another big subject to handle because of altitude, not just the high voltage. And a lot of those, but that's step by step.
How about this? If you can't talk about your solution, which I totally understand, can you talk about the problem? So what is the problem when it comes to hydrogen's potential volatility in gaseous form and the application of that on an aircraft in general?
So you said the two main problems, you're right, it's volatility, but especially the volume and the mass of the tanks, because the tanks are 5 to maximum 7% ratio. So you need to carry less and weight a lot. That's why we buy the tanks on the shelf, but we are not here to redesign the tanks because they are already certified, bulletproof, and way more.
But you did mention you're not hanging them on the wings like a jet would do. You're actually putting them below the cabin, is what I heard. So you don't have to go into the design reason for why, but maybe you could talk about some of the challenges in legacy design.
Yeah, I can. Exactly. That's why we use segregated tanks. We don't have just one tanks. We have 6 tanks today. And it may evolve, but that's where we are. We have 6 tanks today, each 3 and 3 for each powertrains. And we put them below the cabin because they are very volumic and massive. That means that they can balance the aircraft. So in case of any leaks, for sure you have 1,000 of captors everywhere, but that's conventional. It's not just Beyond Aero. Every car's boats have that already on any hydrogen leaks.
So there's a weight balance problem because from a volume perspective, you need more hydrogen than a jet would need kerosene.
Exactly. So that's why we have decided to put them below the cabin. It's difficult to explain without any drawing, but because of the volume and the weight, if you put them behind the cabin, the aircraft will be unstable. It's going to fly like that. So you need to really be as balanced as you can. So that's why we put them below. They have other issues, especially on the certification side. This is something new. So we need to work with EASA on that. And it's also the key for any hydrogen leaks to have captures, but especially segregated tanks, because you can cut with any valves. You have different valves. You can cut any leaks if that happens, worst case scenario. So to put them, and that's key, in a non-pressurized area. That means that you have a valve that could open and take the air from outside and also clear any hydrogen leaks. That could eventually happen, but that's something that is well mastered today. Not just Beyond Aero, I'm saying this is a state of the market, level of maturity of every cars, boats, and everyone.
And then anything in particular you want to add around challenges of cooling?
Cooling is key. I told you about the air intake. The downside of that is that it's creating a lot of drag because I don't know if you see on the fighter's jet, for example, you have they are more used to cool down the complete propulsion system. But we do need a huge air intake system somewhere. I told you we put it above the fuselage between the 2 electric engines, but that's why we have a huge drag. So it's not as much as efficient as a kerosene aircraft could be. That's why we only have 1,000 miles. But still, this is for us a good compromise of that's the price to do an electric aircraft. It's not as efficient as kerosene, but we can still reach 1,000 miles, 80% of the market, And like I said at the beginning, it's only step one. If we could do liquid hydrogen, we're going to have smaller tanks, but that's minus 252 degree. So you're speaking in degree in Europe. And that's not stable also. It's always, you have a complete loop. It's boiling always. It's complicated. So these are the challenge.
Liquid hydrogen needs to be stored at a colder temperature than gaseous hydrogen.
Absolutely. Less pressure for sure. So it's pros and cons. Nothing is perfect. It's always what's the market first. So what's the market, the need of the client? And then you design something according to your market. Is it speed? Is it range? Is it CO2 emission? The architecture of today's aircraft have been made for mainly speed and efficiency, where I think the society of tomorrow won't be the case. It's really electric first, the emission that is going to produce. For sure, you need to find a balance. You cannot be as too slow or very short range. You need to find a good market. And that's why we start with a business jet. It's a small aircraft. It's not 40 seats, or as a startup, it's a big project, I recognize. But if you compare also to 15 years of Airbus program, it's not the case.
Let's talk about relative to some of the solutions that are happening in large commercial aircraft, where it seems like the industry is starting to coalesce around sustainable aviation fuel as a solution, as a drop-in replacement, assuming it can get to price competitiveness and production volumes that the airlines are comfortable using. That means they don't have to go deal with all of the capex they've invested in their aircraft for decades. They can just use the jets they already have and change their fuel source. How do you see that evolution happening on the commercial side and on the larger jet side relative to your chosen model of smaller business jets?
I think it's the right choice on the short term. Like you said, they have assets. It's very difficult for them to say, okay, let's do a pivot, and we put everything on the drawing, and then we start clean sheet design again. 2 companies have been able to do it, and the famous one is Airbus. Airbus is working on hydrogen aircraft. It's not alone. Where it's working with Europe, with French government, and that's why also it's important to be in Europe as a start on those subjects. But Airbus is working on clean sheet design, hydrogen aircraft, a bit of fuel cells, but also combustion chamber, also burning the hydrogen.
They're attempting both solutions today from a hydrogen perspective.
Yes, liquid, because it's bigger aircraft, and because they are doing more 100 seats, even more, they do need combustion chamber, not as we do. So that's the good news. That means that some are really daring to bet a lot on that and to do the move. Some are not yet, maybe for culture reason sometimes, or it could be economical reason or technical reason, or because they are on a market that do not really need it yet, or like you said, because they believe more in SAF, on short-term solution. But you ask me what I think on the short term, we have no alternative solution than SAF. It's absolutely not the long-term solution. And like you said, it's more an excuse for some of them to say, hey, that's enough for the moment. But I think the market need is changing, especially in Europe. In France, people don't want to use any plane anymore, not just jets, also really commercial airlines. Market need is changing. The maturity of the technology is there. We can buy the electric engine, we buy the fuel cells. And now that Airbus is driving the whole market with hydrogen aircraft, the certification entity, so EASA, the equivalent of FAA in Europe, is working on hydrogen certification. So it is really happening. For me as a startup, I'm not even talking about Beyond Aero. I'm saying it's happening in the whole market. It's too slow. We should go faster. I really hope everyone could take the move and could do it. But as a startup, we go faster with a small aircraft where existing technology don't require 10 years of certification, but where the market need is strong, technology mature, and certification timeline are faster.
Let's talk about France. You have a video clip of President Macron of France 6 months or so ago actually naming Beyond Aero and talking about the future of aviation. So clearly in France, it seems like hydrogen and small electric aircraft is absolutely a priority of the current administration. Can you share a bit about that and what's driving that development and interest?
3 things. I'm saying them again, but market need. I think on a cultural aspect, we are very sensible to the alignment of the Paris Agreement. very dedicated to the climate change, to fight for it. And people are plane bashing. You know that? You know this phenomenon?
PJ shaming, I think we call it in the US.
Yes, exactly. Especially in Europe and France and Netherlands also, but really, really France. So first, cultural, market need. So that's the first thing. Second, because of Airbus, you said who is driving, why France? Because Airbus is a huge part of its capital is French, but mainly because 75% of our electricity in France is coming from nuclear. We have nuclear energy. That means that we are one of the only country that could create pink hydrogen, so low carbon hydrogen from nuclear to powered aircraft. And since Airbus is working on hydrogen aircraft with Europe, with Macron, it's a complete massive pivot from airports, from hydrogen providers, distribution, certification, OEM, so Airbus, suppliers, Élysée, everything. I don't know if you know, but there is a plan called 2030 France. You know that? It's a plan of Macron.
I saw him mention it in the video I saw where he named you, but I don't know that I know the details of it.
Well, it's amazing what's happening in France these days, not just in aviation, but in a lot of things. You have this 2030 France plan. It's for 2030, on this 10 objective, we should reach these requirements. And one of the 10, you have a food tech, you have agriculture and thing, and one of the 10 is low carbon aircraft in France. In total of that, you have $54 billion given by the French government to invest in those 10 verticals, to really reindustrialize the country and a lot of things. That's Macron's plan. So that's why Macron is pushing for this plan for startups and big companies, but especially startup because he's, the French tech. He's really driving the movement. So 54 billion on these 10 verticals. And one of them, low carbon aircraft. We are not a lot of startup doing an aircraft in France. That's why he did quote Beyond.
The video I saw, it was something like 200 million euro specifically into small hydrogen electric aircraft, right? It was a very specific allocation of capital.
Free money in grant. Crazy. France is amazing. You ask why? Well, because of Macron, because of Airbus, because of cultural reason, because of the level of maturity of the technology. It's a complete pivot.
Hey everyone, I'm Yin, a partner at MCJ Collective, here to take a quick minute to tell you about our MCJ membership community, which was born out of a collective thirst for peer-to-peer learning and doing that goes beyond just listening to the podcast. We started in 2019 and have grown to thousands of members globally. Each week, we're inspired by people who join with different backgrounds and points of view. What we all share is a deep curiosity to learn and a bias to action around ways to accelerate solutions to climate change. Some awesome initiatives have come out of the community. A number of founding teams have met, several nonprofits have been established, and a bunch of hiring has been done. Many early-stage investments have been made, as well as ongoing events and programming, like monthly Women in Climate meetups, idea jam sessions for early-stage founders, climate book club, art workshops, and more. Whether you've been in the climate space for a while or just embarking on your journey, having a community to support you is important. If you want to learn more, head over to mcjcollective.com and click on the Members tab at the top. Thanks, and enjoy the rest of the show.
The pink hydrogen that you mentioned is a big aha for me, which is that France can have an advantage in hydrogen production from a clean hydrogen perspective. Obviously, the US, for example, has significant natural gas resources, so can generate, what would that be, gray hydrogen, I think?
Gray, and if you carbon capture would be blue.
There we go. The colors of hydrogen are still something I never quite get right. But the idea that France can generate nuclear, essentially zero emission hydrogen at scale is super interesting. How do you see the hydrogen supply chain needing to change to support your company at scale?
It's a massive pivot, absolutely, to support at scale with low carbon hydrogen. I'm saying low because it's never zero. You always have the cost of transportation and everything. But long story short, could be zero. But I'm trying to be careful on that. It's never zero. If we just buy the hydrogen today, does not need such a deep transformation. Because I told you, cars exist already, and you have more than 300 cars, taxi in Paris running with hydrogen. So you already have the hydrogen infrastructure to have the pump and the compressor, and you have what you need already. But if we do want low carbon hydrogen, in that case, you need a complete massive pivot. And that's why you have a lot of public money. For example, only in airports, it's DP, Airport de Paris. They are really, really doing the tour with Airbus and the French government and moving forward and pushing forward the hydrogen infrastructure. So you have different scale. Massive scale would be pipelines everywhere. Middle scale could be either you produce hydrogen on site or you deliver it by trucks or by different things on the main airports. But very short term, we have made estimation for prototype, but also for the aircraft. You can deliver it with a truck. So today it exists already, the 1 ton truck of hydrogen. So you can, exactly as kerosene, they are coming in the airport, they open the gate, you need the infrastructure there to store the hydrogen. On a short scale, and that's why we are building a small aircraft, also a CS-23, it's below 8.6 tons. So that's why, yes, there is a massive pivot, but coming back on a very pragmatic level as a startup, with a small aircraft, you don't need that much hydrogen also as a start. So that's why it makes sense to do a small aircraft first, to do just back and forth in the main cities, because we could have hydrogen in Le Bourget, the main business airport in Paris. And then step by step, the whole ecosystem is moving forward. Just to finish here, EASA is called Alliance for Zero Emission Aviation. So it's a European level of workshops every month that we speak all together around tables of, okay, where are we? How do we do with the roadmaps? It's an alliance. That's really the good wording.
You mentioned this as a big pivot for France to be able to implement. When I think of an equivalent size potential pivot, I think of EVs and I think of Tesla and the fact that Tesla not only built the car, but built the distribution system of the chargers. And I wonder, for a company like Beyond Aero, do you feel like you ultimately are going to need to expand into supporting those distribution systems? Or potentially are the bigger companies like Airbus going to help build those out and you'll be able to leverage those platforms as they're developed?
No, that's the beauty of Europe and France, is that indeed it's all together. We don't expect to do that, if needed for sure, but today it's not the case. But we do need partnerships. We do need to work together. It's already the case. We already have public partnership with Airport de Paris and hydrogen providers to express our needs, our technical requirements, the challenge that we could have, the pressure we need. We do need partnership and to work together. And since Airbus, but also everyone else now, everyone is working on hydrogen supply, we should not expect to need, like Tesla had to do it, to do the complete distribution chain also. Worst case scenario, we will. But today, I think it's in good direction.
And how do you see flight patterns and flight behavior changing as we move to hydrogen-powered aircraft? It sounds like there will be more planes taking smaller flights as opposed to big, giant planes taking longer distance flights. Is that how you would imagine the world looking?
First of all, not even talking about aviation, we should all make an effort to pollute less. And a huge part of our annually CO2 emission is transport, and especially aircraft. So I am the first one to say, if you want to make an effort, it's good to work on a technical solution, which I'm doing, but first, sobriety. First, be careful about what you do. So in tomorrow's society, I think we should, unfortunately, be careful about just flying everywhere, just for a meeting, or try to maybe take more the trains, especially in Europe also. In America, it's a bit different. The train, or think twice before just jumping on an aircraft. So that's first thing, sir. First is sobriety. And second, technology will help to solve a part of the challenge, but technology is not the solution. It's a way to move things, but sobriety first. So yes, I think in a second movement, we're going to have electric aircraft. I said it at the beginning, aviation will be electric. That's a complete vision. Hopefully it's not just 50 years. It's going to be in less, or worst case scenario in 100, but it's a question of when. So we will need to adapt a bit to the new constraints of electric aircraft. They're going to be a bit slower. Maybe we're going to have less aircraft at the beginning, smaller range also. But at the end, I think this whole society is changing and the needs are not going to be the same also. So it's a double effort, technology, but also sobriety.
So speaking of sobriety, let's tackle the question of business jets, private planes, all of that in the first place, some would say, hey, we should just regulate this stuff away. We shouldn't have any of this stuff. Why do people get to have such an outsized emission footprint just because they're wealthy as an individual? I think you would argue potentially that if you can solve this with lower emissions, fuel sources, you actually can create greater efficiency in this way. But I'm curious how you think about those who would say, hey, you're just solving a problem for wealthy people anyway. What's the deal?
Well, there's two ways to answer. First, they're right. They should be taxed and stopped step by step. We should not do it drastically. Otherwise, the markets we are closing, for example, in Europe, France is taxing private jet. People are just going to put their aircraft in Belgium and fly somewhere else. So it should be globally or not at all. Otherwise, just closing some markets is not something the issue. But unfortunately, private jets emit, you're right, 2 tons of CO2 per hour. It's crazy, 2 tons per hour. We have to do something there, but it's also as a startup, step by step.
I saw a stat from you, I think, that said that private jets are 10 times more polluting per passenger than a commercial jet, which makes sense, obviously, if you think about it.
Yeah, that's why we start where the need is strong on the market. And you're right, they are publicly bashed. That's why the market need is a good choice as a startup. Those who will say you should start with 100 aircraft, 100-seat aircraft and 40, I'm like, okay, but this is unrealistic as a startup. It should be done by existing aircraft manufacturers. I'm not going to quote anyone, but we should all work on that. But as a startup, it's already difficult enough to build a technical level, but especially to raise the amount that we need to raise and to certify with a small aircraft. That is not realistic to start with above 8.6 ton aircraft.
What's the size of this market? How many business jets, business planes, private jets are there out there? And how many of them do you think realistically are going to or could move to hydrogen as a solution relative to sustainable aviation fuel or relative to buying an electric or hybrid electric, battery-powered hybrid electric plane in the future?
So the business aircraft market is $30 billion. It's huge. We don't know it. It's a very special market.
That's just in purchases or that's in flights? Can you break that down?
It's 22 million new aircraft purchased and 10 to 15 of second-hand aircraft. You buy a second life to the aircraft. So a total of 30 billion. There's 23,000 jets in the world today. 15% of them are in Europe and 60 in America. We have discussed about it. We start in Europe for climate, for cultural reasons, for Airbus, for all of the reasons that we have said. But 60% of the market is America. Eventually, we need also to switch. Question will be when, but we will. It's a huge market. It's separate in different sizes of aircraft. I told you CS23. That means short court, let's say below 8 person, 8 seats.
Would this be considered like a light jet? Is that sort of how you would think about it?
Exactly. That's what I was going to say. You have turboprop, very light jet, medium jet, heavy jets. You have, a complete range. You ask how much of them could be substituted. So if you take only a concrete study from the Paris Le Bourget main business airport, flying less than 600, so it's in kilometers, in miles, it's 500 miles. CS23, that means below 8-seater, flying less than 500 miles. Every year, you have 103 distinct aircraft. So the market, only for the Paris Air Show, doing back and forth on small range, below 8-seater, would be $1 billion for us. So the business case for me is very clear, is we start with a concrete case study from London, Paris, Geneva, Nice, Madrid, Berlin, and then we expand step by step. So that's why I don't say a private jet, first because technically it's not a jet, but second because it's more like a business commuter between the main cities. Only the Paris go-to-market would be $1 billion. So that would be 103 distinct aircraft. If you cover Paris and Geneva, you have 200 aircraft and scale more and more and more. So I'm pretty well convinced of the business case. I told you aviation will be electric. We start with this go-to-market, but it's going to spread.
And just to clarify on the dollars, because I think we had a million billion mix-up, but you said it was roughly 20 billion in new jets purchased per year and roughly 10 to 15 in used purchases per year, billion.
Yes. Last year, it was 22 billion of new business aircraft and business jets brought, period.
Wow.
An aircraft is expensive, so the number is it's huge.
From a routes perspective, with your range, you said around 1,000 miles, you're able to travel a good chunk of Western Europe in that sort of route profile, I'm guessing, as well as in the US, you're able to travel a good chunk of, for example, the Eastern Seaboard with that size profile. Is that correct?
Yes, and ironically, we cover more routes in the US than Europe. It's weird. Let me explain. Because in Europe, we cover 80% of the routes of the main flights. Because London, Paris, Geneva, Nice, and the range between the cities is bigger than most of the routes in the US that are San Francisco, LA, Las Vegas. And this market, only these three cities, is way bigger than these routes in Europe. So in the US, we could cover 86% of the flights because just going back and forth between San Francisco, LA, Las Vegas as a go-to-market. Only that is already more than 4 years of production for us.
So comparing your plane that is hydrogen powered and the types of routes you can cover, how does that differ from a fully battery powered electric plane or even a hybrid battery electric plane?
Lithium batteries are very heavy, too heavy to have 1,000 miles. The average, even with a clean sheet design that we can see, is 200 miles. So it's really another order of magnitude. It's really another market. With 200 miles, it's more regional routes, or it's more little islands between one island to each other, where we really cover the main cities. It's really not the same market. And that's why we are really more like a business aircraft, where small lithium batteries aircraft, either they are individuals, pilot lovers of aircraft, which is a market, so it could be also pilot training. But for me, it's more a smaller market, more niche. That's going to happen. And I do believe whole aviation will be electric. So you're going to have lithium batteries for smaller range, but that's not really the same market at all.
So you're saying that'll be more of a pleasure aircraft, for example?
Or training, or some islands use case, or regional. It's another one. But it will exist. And I do believe in this market. I'm just saying our strategy is really to start with a business jet because hydrogen clean sheet design can allow you to go 5 times further away than lithium batteries, 1,000 miles.
In the hydrogen space specifically, we've talked about the work that Airbus is doing with their Zero-E designs. And then you also have a few other startups in the space. You have Zero Avia, which is building other planes. You have Universal Hydrogen, which I believe is building more of the powertrain. How do you see, I guess more specifically, maybe Zero Avia as being different from the work that you all are doing?
Today, we don't have any direct competitor. Direct means CS23, business, clean sheet design, hydrogen fuel cells, powered aircraft. No one is doing exactly the same as we do. So the whole ecosystem is more, I would say, indirect. And it's good because we should all completely decarbonize the whole aviation, not just some parts of it. For me, it's complementary. I don't see any competitor mindset over there.
Talk a bit about the financing you've raised. You all went through Y Combinator, I believe, a couple years ago, maybe?
No, last year, 18 months ago.
Oh, wow. Amazing. What has transpired since then?
Oh, everything. Everything changed so fast. Well, before YC, we already did a round and we were already 10 in the company. It was not a YC slide company. We had a company, we were 10, we had a prototype working already. And YC was more the opening of the US side for us. So now I'm based in LA. We have offices in LA and in France. We did a public reveal of the design of the aircraft only last June. I was telling you at the Paris Air Show Le Bourget last June. So before that, for a year and a half, no, almost 2 years, we were more in stealth mode by working on this clean sheet design. I don't like to speak when we have not done the calculation. Even if the design is still going to evolve and be detailed more and more, it's never fixed. I wanted to wait before showing any aircraft or speaking about range or something that we were not sure that we could do. So for 2 years, we built a team. We worked on a subscale powertrain that is already working. That's good. And then we worked on the clean sheet design aircraft. Now we have identified our suppliers and we know how to scale. So total of 24 million cumulative raised. So it's only the beginning, but it's a good start.
Have you been able to tap into that French government funding that you mentioned was coming available?
Yeah, a lot, but I won't say. how much.
That's great. Congrats. Let's talk a bit about you. We haven't talked about your background and how you decided to go build an aircraft company in the first place. Walk us through your journey and how you got to starting Beyond Aero.
Long story or short story? Because a lot has happened, but no, for sure. So was born and raised in a very, very small village, west coast of France. You had more cows than people. And I was just doing two things, looking at the stars and doing sports. So as soon as I could, I left home at 17 and I said, okay, I want to become an astronaut. I remember to type on the parents' computer, big ones at the time, what are the best schools to become an astronaut on the old Google interface. And I realized in Europe, you have one school, it's called Sustainable in Toulouse. There's a school of Thomas Pesquet. Or otherwise it was Harvard and the classic fire or military. So from that, I'm like, okay, either I become a fighter pilot, it was plan A or plan B equivalent. And then it's like, okay, let's go to Supaero. So I did work hard on mathematics and physics for 3 years. And then I went to the school. And in first year of aerospace studies, I've met Hugo, my co-founder. And actually we've met on a startup weekend, not on the campus. And our first project was a Hyperloop. You remember at the time, everyone was building Hyperloop. It was called Unstoppable. We really worked well together. We did another startup for 18 months. It's called Atom. The idea was to put micro supercondensator in smartphones. So supercondensator, the idea is to recharge your phone in 2 seconds, 1.8 seconds, with a maximum peak of power in a few seconds. Then so it was a device that you put on your phone, and then you can exchange energy between each other. So that was a very good startup. We had a few prize and investor, 7 interns in parallel of our engineering studies. Then we did a double diploma in entrepreneurship. That was who we are. And we quickly realized that we liked building stuff instead of being the engineer on one only subsystem. Hugo, he's more the profile of the prototyping. Crazy in a good way, but prototyping crazy guy. He worked on a solid booster for rockets. He worked on a lot of different projects. And then we went to École Polytechnique, another good school in Paris. And then we did entrepreneurship master in HEC. And then we went to Berkeley for a 6 months exchange program. 4 months exchange program to learn to launch. That was the name of the program. So how to raise funds, how to build a company and stuff. And at that time, we've met Valentin, our third co-founder of today, who was working at Safran in electric engine and flight test. And he was actually talking on the certification side. And Hugo and Val were talking on, hey, can I power your electric engine with a fuel cell? Because you worked on a fuel cell drone. So that's how it has started, more on a technical subject. And I was working on another company on the side. And then COVID happened. So we're like, okay, back to this little village in France where there is nothing. And I was supposed to be graduated of Berkeley, the end of the studies, and start my company in California. And actually nothing happened. Back to France. So I have this deep frustration of I've done 8 years of study, 11 different type of startups or more or less companies. And during COVID, just be back on this little village with no project, no graduation, nothing. I'm like, okay, we didn't have any money yet because Berkeley is so expensive. So Hugo and Val were working on this idea of power fuel cells, to power an electric engine. And they called me and they're like, okay, Eloa, maybe there's something there. What can we do on the business side? And then at the time during COVID, Airbus and France have started to pivot around hydrogen. So I said, okay, for 3 months, I'm just going to do clients interview. So we did more 200 interviews of pilots, airlines, different type of suppliers. Where is the technology? What can we do? And this is where we have understood to start with a business aircraft because of the client needs, because of the technology on the shelf, because of the short certification timeline. A lot of things happened by the time, but we did manage to raise our first million. It was 1 million in France during COVID. Hugo finished his prototype as proof of concept of the architecture of the powertrain. And then by that time, Valentin dropped out of his PhD and he started to work on this clean sheet design of, okay, what if we rebuilt everything from the start? As a startup, that's the beauty that we can do. So yeah, that was brought up of everything that happened, but actually entrepreneurship mindset from day one and with a strong passion with aerospace from childhood.
I love hearing those stories, and I feel like I should ask you that question at the very beginning of our conversation, but I'm glad we got to it and you got a chance to share your background. The last set of questions I want to dive into is just what's next? Where is the airplane from a design and production perspective? Where are you from a commercialization perspective in terms of pre-sales or working with distribution pathways at airports or anything like that? Where do you see the company going over the next few years?
First, short term, we make our prototype fly.
There we go. That's always a good thing for an airplane.
Yes. We did manage to do the mission profile on the ground. That means that we reach the maximum power in time that we need to do as if it was flying. That was a good success for us. Now we put it in the air as soon as possible. That's a good milestone. Second, we continue to grow the team and to validate the design that we have already detailed more and more, but now we need to go in detailed design phase with suppliers. We already have chosen our main suppliers, but we need to have plan A, plan B on everything. Then it's a normal aircraft program. I'm not reinventing anything on the certification timeline. So that means design first, then testing, ground testing, then flight testing, certification in parallel, and then production. So we are dreamers, but realistic and pragmatic on the way. So we don't have a delivery date because of part of the certification do not exist on hydrogen. So it would be crazy to give any dates. What I can say is that this type of aircraft are usually certified between 5 to 6 or maximum 7 when there is an issue years. So as a startup, we could go faster on some subjects, but longer because of hydrogen. So in average, could take 5 to maximum 6, 7 years. So hopefully it would be aligned by 2030 plan of Macron. But step by step. I know it's going to be a long journey. We are resilient, prepared. We have been waiting our whole life to do that. We have the right go-to-market, the right market need, the right technology, the right team, the right certification, the right momentum on the market. You know, it's all about timing. You remember a famous video, all about timing? This is happening. I told you at the beginning, it's going to be electric. It's a question of when. So we're going to take our time to do things right with the right people. And that's what I love.
You are clearly, I think, working on a generational problem, and I really appreciate you taking the time to come on here and share more about your plans and the why behind Beyond Aero, and also where you are with respect to all of it. So, Eloa, anything else I should have asked that we didn't cover today?
What's next after this aircraft?
There we go. What's next after this aircraft?
What I can say that this aircraft is called one. So they're going to be another. Maybe
there'll be two.
3. Or 3 or 4. We'll see.
I love it. Well, hey, thank you so much for your time today. This was fantastic, and I appreciate all that you've shared with us.
Thank you for your time and your very thoughtful questions. Thank you very much.
Thanks again for joining us on the My Climate Journey podcast.
At MCJ Collective, we're all about powering collective innovation for climate solutions by breaking down silos and unleashing problem-solving capacity.
If you'd like to learn more about MCJ Collective, visit us at mcjcollective.com. And if you have a guest suggestion, let us know that via Twitter at MCJPod.
For weekly climate op-eds, jobs, community events, and investment announcements from our MCJ venture funds, be sure to subscribe to our newsletter on our website.
Thanks, and see you next episode.